So now let's discuss about optical sensors. Before getting into this, I want to discuss about photoelectric effect, which is found in the long time, more than 100 years ago. So there was a phenomenon observed that on a metal surface, when experimenters send a light, such as visible or UV light, and that light rays somehow eject electrons from a metal surface. So those are electron emission. That is, at the time, only Maxwell's theory was prevailing, so that we understand the light as a wave. And let's further to see when the light frequency or the color has changed into a longer wavelength or a smaller energy, and somehow these photoelectron did not coming out, even if we give a lot of intensity, which means a lot of photons from our understanding. So this effect is called a photoelectric effect. So why we are talking about this in optical sensors? Because we use this a lot for detecting light in the UV, visible, or infrared regions of electromagnetic spectrum. So this effect is called photoelectric effect. And when the metal surface is struck by light, and its atom can emit the electron, and that is called photoelectron. And the problem is, this effect could not be explained by wave theory of light, because at certain wavelength or higher wavelength, even there's a lot of photons, lot of light intensity, it never give out photoelectron. It wasn't understood until Einstein explained this as a beam of light is not a wave, but a collection of photons, and introduced the energy to this single photon as Ha nu, and which is described in here. H is a Planck constant, nu is a frequency of the light. So that electron is, so this effect of the metal is we call photocathode. Cathode is a place where electrons will be ejected, okay, depart. So metal surface on which the beam of light is shown and emits electron. And that electron is we call photoelectron, which is ejected from the metal. And of course, electron, as you know, electron is a particle with a charge, negative charge. And that electron flow of electron over time, we call it as a current. So we call this as a photocurrent, which is shine a light on a conductive metal surface that can cause a flow of photoelectron, and that, over time, the amount of charge is called electrical current. So that Einstein's explanation of this as a photoelectric effect and introduction of the concept of photon as a light as a particle kind of changed the whole idea and introduced the emergence of quantum mechanics. So that particular paper was proposed in 1905 on a heuristic viewpoint concerning production and transformation of light. And because of this, Einstein got Nobel Prize in 2021, not for his even more famous discovery of special and general relativity. So the experiment shown, this photoelectric effect is shown here. You see the light with a filter having only this blue or specific wavelength of light comes in, and this is a cathode, okay? And that electron ejected will come out to this electrode, and you can measure the current, and you can change the voltage to measure this binding energy or work function he proposed later.